Hi, my name is Marco Cantu. Welcome to this CodeRage 9 session focused on enterprise mobility services and specifically on working with SQL databases when building mobile applications that hook to your remote enterprise data source. My name is Marco. I'm product manager at Embarcadero Technologies for Delphi and RAD. And this is my contact information by email or Twitter, where you can engage into conversation during CodeRage 9. So what the specific focus of this session, as I was mentioning, it's looking into data and mobile challenges, comparing different solutions on the mobile data space, and then focusing specifically on what enterprise mobility services provides from this perspective and delving into some actual demos of using FireDAC with this technology. It's not an exhaustive session on enterprise mobility services. There are others in the program of CodeRage, so the focus here will be specific to database side and less focused on the analytics, the core API management, and some of the other areas of the product covered in specific sessions. So data and mobile. We all have mobile devices and they won't be terribly useful without the ability to access to data that lives outside of the device itself. That's even true for most games that require internet connections. Mobile data access is not client-server access. There are technical ways, in some cases, in some scenarios, to do direct client-server access from mobile, but the lack of drivers for most databases, in some cases, licensing issues for those drivers, but also connectivity issues. When you're connecting from mobile, you might move from a Wi-Fi to another Wi-Fi, from a Wi-Fi to a 3G connection, and your IP address will keep changing. So keeping an active connection via TCP/IP is generally a mistake, even if you can go through VPNs and similar technologies. And last but not least, there are security concerns in opening up the access to the database server from the outside, because you really want to have a well-guarded entry point, possibly via HTTP or some clean standard that you can monitor actively for access. So what ends up being the most common solution for getting enterprise data on mobile is some remote storage and based on multi-tier technologies. Now, there are many different approaches, but we can somehow summarize them into areas. One, you build your own web service with some SDK. Could be a manual, low-level web integration. Could be something like DataSnap that we offer. Could be other solutions, depending on the technologies. Could be Java, .NET solutions that you deploy for data access, and then you simply create REST clients on your devices. Or that's getting more and more popular, specifically in enterprise scenarios. Rather than do it yourself, deploy a ready-to-use solution that allows you to hook into the specific data access that you need, but without having to reinvent the wheel and redeploy and rebuild an entire custom solution. That's what's generally indicated as MEAP, or Mobile Enterprise Application Platform. Now, there are different scenarios that can be used for different types of data access. And again, there are dozens of different variations, but we can somehow summarize them in three categories. One is pure cloud hosting. A good example would be you have an application that saves files and you want those files to be backed up on your personal cloud. Could be Dropbox, could be Amazon, could be Google, could be Microsoft. Doesn't really matter. You as a user have an account on this cloud system, and you have your documents backed up to that cloud system. This is user-based. It's not, or it's generally not, the application that offers the data access, although Dropbox will be an exception to that rule. But it's not the mobile-specific application that provides that access. This is what happened with BAAS services. Backend as a service providers offer you a solution that's not user-specific, but it's application-specific. So you build an application and you have storage for all of the users of that application. This a solution that scale, offer great social integration. They're generally based on vendor clouds, and offer some data storage in terms of specific tables, specific data structures that can be used. But it's basically an end-to-end closed solution, meaning your application and the backend create an ecosystem that is self-sufficient, but won't easily connect to the outside world. This is where the big difference comes with MEAP solution that are meant for corporate users, tend to be slightly more expensive in terms of per user cost. But the goal here is not to have their own application data, but be a conduit to the enterprise databases that you need to access to, whether sales, whether inventory, whether warehouse management, whether any other thing you're doing in the business side. You can generally have its own specific or particular data storage, but it needs to hook and provide access to the real data that is used to run the company. The other thing that's very important for this mobile backend solution is, rather than having them on the vendor sites, they can be self-hosted. This means you provide your own security. They are behind your firewall and hooked to your enterprise databases with a secure and safe connection, and are also scalable in terms of, again, data access. Now, you can cloud host them. If your data is in the cloud, then it would make sense to have also these services hosted on a cloud provider. The other thing I want to mention to complete the roundup on data, we do have data that lives in the cloud or on MEAP or enterprise databases. However, it's usually a hard call not to have some data on mobile, if just for caching. If you have to re-download description of thousands of products you're selling every day, or every time you run the application, that would be a complete disaster in terms of bandwidth usage. But there is more. You might have temporarily lose your connection and still want to be able to do things and collect information and even enter and edit your current information for later synchronization with the servers. So caching, keeping local data are relevant features to having data on the device, readily available when the applications get restarted. Now, there are security concerns in this scenario different than the connectivity concerns or hackers getting into your system. Here the concerns becomes, what if I lose my device or the device gets stolen and someone has an option to look to the physical files that are there. It might be an issue, it might be not. It actually depends on which data you are saving and how security and how you are managing any sensitive data that might even be legally concerning to if it becomes available to the outside. Now, there are multiple grades of solutions in RAD Studio. You can use local tables. Just grab an FDMEM table and save it to a binary local stream. and you are in business for local caching, now that means that the table is going to be reloaded in memory, so it's great and it's extremely powerful. You can even do joins of multiple FDMM tables on your local device as if it were a full database. But if you have thousands or hundreds of thousands of records, you might want to have a local full database because it reduces the memory footprint. You're just querying the local database and loading a bit of the records at a time rather than loading them all. So IB Lite is a free solution that scales better and provides reduced memory footprint in some of the scenarios. Really depends on what you're actually doing. IB2Go is the next step because it's technically identical to IB Lite in terms of reduced memory footprint and capabilities, but it also allows for encryption of the database data. So you can get to a fully secure application end-to-end, not just making the connection to your backend secure, but also keeping a secure local cache on the device that prevents anyone from looking to your company data in case they can get a hold of those files. So EMS is a MEAP. It's one of the solutions that you might want to use, again, depending on your scenarios. You might be better off with a BAAS, you might be better off with a cloud service, you might be better off with a completely custom SDK, but we are pretty sure that EMS offers some significant advantages to other scenarios if enterprise data access is your goal, because it's fast to build and it's fast to deploy and still provides a lot of flexibility in terms of deploying both on-premise or in a private cloud. It has security focus and it has a lot of other features already and more to come later, including right now, for example, the usage analytics and the REST API calls analytics that are part of the box, and nothing to do, you just deploy it and you get analytics readily available with really no effort. If we look at the entire picture, there are a few areas where databases come in. There is an Interbase2Go license included in EMS for securing the data on the device. There is an EMS database, which is actually an Interbase server that keeps the information for the console, the users, the analytics data, and more. And then there is either Interbase server, which is included for free if you want to use it, or you can hook to any other enterprise database through FireDAC. You can also have conduits to some of these other cloud and BAAS providers if you need that. But in the most common scenario, you'll just use FireDAC in your EMS plugin packages to connect to enterprise data. So as a roundup, the EMS architecture has a server that lets you expose REST APIs. There are some already built in, but you add more, creating custom packages that register new resource URLs. The EMS database stores some of the information, and then there is a console, which is another server that has a web interface and used for tracking status and usage. To deploy, you can deploy the EMS server and console as standalone servers with a limited user license for development, and then you can deploy ISAPI libraries that are more efficient and are distributed separately from RAD Studio itself. You can run on Win32 and Win64, integrating on either versions of ISAPI, and use either Delphi or C++ Builder to build these packages that are deployed along with EMS. So an EMS package is just a package library. So it's a DLL with specific entry points. Each resource that you add to a package is mapped to a URI, a URL ultimately, a name that is part of your resource reference from your REST, client REST calls. you can have an EMS server can load multiple packages, and each package can expose multiple resources. So you really have quite some flexibility in that respect. When you're using the EMS Package Wizard for the first time, you can add a resource, or then you can add further resources later on with the EMS Module Wizard. On the client side, the client can make any REST API calls with any technology. If you want to have a easier approach, use the EMS provider that also allows for all of the security and user management and login information that's needed. And then you can use some of the BAAS components like the backend endpoint or the backend user to interact with your EMS server. In the most simple scenario, just use an EMS provider with a backend endpoint, as we'll see in a second, to hook to your server. There is also a FireDAC client component that simplifies some of the code for interacting with FireDAC-based EMS servers. So, specifically talking about EMS and FireDAC, and that's the last thing before we get into demos, you can manually do JSON streaming of your FireDAC data, saving to stream and loading from stream with the JSON format. And that's actually the first demo we're going to go through, because it helps understanding the steps that are behind creating an EMS FireDAC server. Or you can use the more sophisticated FireDAC schema adapter that captures master detail relationships both on the server and on the client, and allows you to do streaming of this master detail structure rather than returning separately the individual database tables. So, as I was mentioning, let's start looking at a demo that I've built, and it's an EMS server and an EMS mobile client based on FireDAC, custom streaming, and EMS provider plus backend endpoint component. So how do we actually build an EMS server application? We go on the new C++ builder project, the EMS section, create a package, and either an empty one or one that already has a resource. There's another wizard you can use to add further resources to the same project later on. And then in the resource, you specify the URL that you want to be used. And then you can determine which of the endpoints, which of the operations you want to support. And there are post, get, put, and different types of operation. To keep things simple, we're just going to fetch data using a get method. Now I have already done this, so I don't need actually to go through this step. And the result is this project with this package, and the package has a data module. Now in the data module, I dropped in an employee connection, a connection to the Interbase database. I have a query that is quite simple, and I can try out just to make sure everything is working smoothly. So a FireDAC query, wait cursor, even if that's not relevant in this scenario. And the other component I need, this component is just a placeholder to get into the proper unit in the project, is the JSON storage support for FireDAC. Now, how are these components combined in code? The code is quite straightforward. I open the connection to the database, execute the query, create a memory stream object, and then the memory stream object is used to stream out in JSON format the query. The resulting stream is added is returned as response for the body of the response itself. So we have three parameters here: a context, a request, a response. We need to fill in the response, and we can also declare this is a JSON structure. So for example, returning this to a browser or a specific client application, it will figure out the content type of the HTTP response. Now, if we enable this project and run, this is a package, it's not a standalone application. So what's going to happen is it will be executed in the context of the EMS server. So the EMS server starts, and we can actually open a browser to hook to it. It's responding to the predefined version command, but we can hook to the data command and actually get our database data in JSON format. Now, if this is working, we can just keep it aside and look at the client side of the demo. Sorry. The client form has actually quite a few components. Of course, you could use fewer components and write more code. In this case, I'm actually going more towards the component models. The first is the provider. The provider hooks to the local host, to the HTTP server where EMS is running. Now we need an endpoint, which is the specific URL we're going to call, and that, as we've seen, is called data. So there will be a localhost, the port / data. And the other thing we want to do, we could just grab the response from the backpoint, but I'm actually pushing the response to this REST response 1 object just to simplify the code a little more. Now we have a response. What we'll manually have to do is to take the response and populate this FDMEM table component. The FDMEM table in turn has got a predefined field, and this is needed because what I'm doing here, I have a list view component, and I'm actually using visual live bindings to connect the list view to the mem table, and specifically to display the full name in the item text. So rather than manually populating the UI, I'm using visual live bindings to populate the UI. By dropping the visual live bindings, you get these 2 extra bonus components in the box. And again, we need the JSON connector to be able to have the proper header files and the proper support for reading back the JSON. So if we look at the code, first of course we have to execute the backpoint, execute the remote request to the EMS server. Then we get back content, and content is a stream. We create a stream for it because we need to call load from stream for the FDMEM table to get the information in memory. And that's it. So let us now run the client. The client opens, connects to the server, grabs the information, and displays everything on the screen. That's it. That's the first low-level step-by-step demo using FireDAC streaming in an EMS scenario. For the second demo, that's more sophisticated, we're going to use the FD schema adapter. This is a rather complex demo that we'll spend a little time looking into, and actually it's a demo that ships with XE7, so you can easily delve into it and figure out how it works. In this specific case, the client is a VCL desktop application that just takes advantage of the local master detail relationship with data-bound grids. But of course, it could be easily leveraged by FireMonkey mobile or multi-device application. The goal here is to look into how FireDAC can use and expose a master detail architecture, because rather than streaming individual tables, we are streaming information from the schema adapter that captures that relationship. The second demo I want to show you is a little bit more complex, but it does use some of the more enhanced FireDAC EMS integration components that are available. So once more, there is a connection. In this case, is a SQLite connection to a local database. the driver, wait cursor, and again the storage in JSON format. Now, rather than having a single query component, in this case there are two query components, and both queries are actually connected to a schema adapter. And the schema adapter is a component that can grab multiple metadata and data from multiple tables and queries or stored procedures for the database. So it lets you work on the group of tables, group of objects in a single unified and simplified way. If we open the code, we can see that the code is very similar to the previous scenario. We have another memory stream, open the two or execute the two queries, but then we save to stream the schema adapter and not one of the two individual queries. The schema adapter wraps and refers to both queries and will create a single stream, including the master and the detail data structure. So the code is very similar to what we were using before. Let's run this again without debugging. Let's open the browser and have a look if we actually do have the proper response. And here it is, all of the tables, lots of data that's sent over from the server. Now let's try to run the client application for this project and see if it works, and then we'll have a look at the code. So here I have a get tables buttons, returns the master and the detail, and let you navigate on master and detail. As you can see, this is a VCL application. It has data module. The data module has no code, but it has the components, database components configuration. So there is a schema adapter. There are two in-memory tables for orders and customers, and there are two adapter components that basically indicate how to grab the data. Queue customers and queue orders are actually the names of the components on the server, and they become the name of the data structure within the JSON structure. And the schema adapter can automatically populate these adapters and that relate to it and get the information for, and the adapters will map to the memory tables. So again, there's no code here. And now if we go to the actual form, the form has this get tables button. It has a provider. The provider hooks to the server. And now rather than having an endpoint, it has a more sophisticated and flexible and ready to use component that's called EMS FireDAC client. This specific client has information about how to actually fetch and post fetch data and post updates. And in fact, there is a single method you have to call get data, well, and a single one for the updates, post updates. When you call get data, what you get is immediately grab the information. The FireDAC client is connected to the schema adapter in the data module and populate through the schema adapter, populate the in-memory tables, and so the information gets automatically displayed in the user interface. So again, very powerful, very flexible. There is a little bit of extra code on the server, but if you look at the client side, the client side has barely no code at all. It's all a component-based configuration and architecture that is able to recreate a master detailed data structure and display it in this case Windows, but of course in a very similar fashion in a multi-device and mobile application written with C++ Builder. So we've seen that EMS is a new solution in the MEAP space. If you need an enterprise data conduit for your mobile application, that could be an extremely interesting option compared to do-it-yourself data snap servers, or compared to mobile backend that are limited in the reach to the enterprise data scenarios. EMS has ready-to-use FireDAC integration, and EMS and FireDAC are going to be further extended to work together even better in the future, although it's already marvelous what you can do with very few lines of code, as we've just seen in the last demo. There is very little glue code you have to write. All you have to do is focus on the business problem, focus on the core data access, and build the UI for your mobile or desktop scenario. There is little you have to do in terms of gluing together, creating the bits and pieces, maintaining the overall solution. You can really focus on the core and have a solution that provides end-to-end security with encrypted database data on device, and HTTPS-based secure connection to the server, and the server that will use a direct behind firewall connection to your enterprise database. So that's the scenario for EMS, and if you have any question, I'm here to answer them, or if you're listening to our recording, feel free to email me at marco.cantu@embarcadero.com. Thanks.
And there was an earlier question, James asked that you answered about where the source code is, and you put a link in the Q&A log.
Yeah, on code.marcocantu.com, there is actually, sorry about that, there is a Delphi sessions area, and in that area there are several components, including several demos, including the demos for this session. There is a CodeRage 9 area, but this is actually outside of it because I already had a few EMS demos for download.
Excellent.
And it's under Subversion, so you can browse online, or you can just use a Subversion client and provide the proper URL and get the specific demo.
And Gregor is asking about the licensing, because there's always some confusion about the 5 licenses for development versus when you need to deploy. You want to explain that again?
Yeah, the concept is that the product, RStudio ships with debug version of the server, and this debug version of the server is licensed for testing and development up to 5 users. There is a separate download, which actually will be available very shortly, which is the ISAPI DLL, which is what you're expected to use for deployment. The ISAPI DLL offers a significantly better performance compared to the standalone Indy-based server. And that has licensing no matter what. So there is not really low number of users free version of the deployment server. And in terms of pricing, the price really varies a lot depending on the number of users. The goal of this technology, as the name implies, is meant to serve enterprises, to serve large companies. And the fact that it bundles the interface to go encryption on devices, actually you can even use multiple devices with encrypted databases for every single user. This kind of explains the price. For one single application, the price might look a little steep, but if you consider that a large company can have dozens of applications all running on EMS with a per user license, this is not per user per app, is purely per user. So if you have like 100 users with dozens of apps, you are just paying for the 100 users, no matter how many applications, how many physical EMS servers you are deploying, and how many packages are loaded on those servers. It's a flat per user fee.
Yep, and again, you can contact our sales offices after you do your development and testing when you want to deploy, and then by purchasing the licenses for users for the deployment, you'll get the production versions of the dashboard, the analytics, the EMS server, ISAPI DLL container, and so on, right?
Yeah, exactly. That's the idea. And the thing that we really recommend as you deploy with ISAPI to actually turn on HTTPS and use the SSL security for the communication from the devices to the server.
And again, it's
something that the developer version hasn't got SSL in it because it's for development, so we don't feel that it's so relevant.
And again, it's the number of users that are going to use the functionality of your EMS server, regardless of how many EMS servers you might deploy. For example, for scalability, you might have several EMS servers on different computers, but it's really just the user licenses that's in a common database, right?
Yeah, that's exactly the point. So if you can have multiple servers that serve different audiences, and in that case, the users basically add up. But if you have multiple servers for load balancing reason, or just because you want to separate deployment, could be there are different backend databases, for example, in different parts of the company. But if a person needs to use services from multiple of these servers, that's again, it's a single user. So it's really it's not a free tool, that's clear. But if you compare it with other enterprise offerings, this is actually the price for the feature you're getting. Again, it's not just the service. It's the service, is the client encryption, is the server database if you need it. If you look at the entire bundle and you compare with other MEAP services, this comes out being quite interesting. And again, the point is it's ready to use. Now, the ready-to-use services might not be dozens or hundreds today, but of course we plan expanding and extending the services that you get out of the box.
And James mentions, let's see, let me scroll up here. He's mentioning about the pricing for 50-user minimum server. He says that puts it out of consideration for his clients who are smaller production target, and I would suggest James just contact sales and work something out, right?
Yeah, that's this kind of the starting point for the pricing that we had in mind. It's certainly possible to consider different scenarios, but again, the goal here is to have these hosted services for a larger company rather than doing some sort of VAR or user management. Now, having said this, we had a discussion recently with a customer that has kind of 100 of customers, each averaging roughly like 5 to 10 users, so maybe something in a similar scenario. But what he's considering doing, was considering beyond EMS, is actually to do hosting. So what he's going to do is going to have a couple of machines on cloud services. He's going to host the databases for his customers, and he's going to host the 100 users. Of course, those 100 users will end up being from different companies, but that's fine. They are 100 users of that EMS server. So again, maybe we need some clarification, but there are potential scenarios where things could work out even in outside a single enterprise with many users kind of model.
Yeah, and that's exactly what James was mentioning. He might have multiple clients, and again, there's however you want to configure it as a developer and deployment with those licenses. That's the number of users who are registered, regardless of whether they're separate companies, separate divisions, separate departments, whatever it might be. And again, I always recommend contacting sales.
That's exactly what I was mentioning. Actually,
Yep.
you know, that second question immediately. But yeah, that's a scenario that works. Again, work with sales, email us for clarification. If there is something that's not clear, we can certainly try to clarify. The intention is to support those types of scenarios where the users are not from one single company, but from multiple companies.
Yep. And Gregor put a question in. JT did his EMS introduction and also the C++ keynote yesterday, and he mentioned about Linux server being in the future directions for our products, and mentioned that, hey, once we have Linux server support, then doing things like putting REST servers, putting data snap servers, and even putting EMS servers would fit into that scenario. Right now it's ISAPI, but I think you have plans for also Apache modules on Windows, and then wherever else we go on platforms, you could use non-Windows APIs, right?
Yeah, absolutely. I mean, the support for Apache was just a matter of fitting in the time for testing and integration. The technology behind EMS is WebBroker, and WebBroker does have support for Apache. So that's just a matter of enabling that capability on our side. We whether wanted to use all of the time to clean up and make sure one scenario worked, and then we're going to extend to multiple scenarios. Now, of course, Apache support is going to also be required for a Linux version, and that's coming, but we don't have a public time frame for releasing that version.
Exactly. So, as Marco mentions, it's a multi-step process. Apache modules on Windows at some point in time, and then Apache is the key to other platforms that are non-Windows, non-ISAPI. So the main thing is get started today and with Windows and using the ISAPI deployment container, and then follow along with us as we move forward into the future and add more deployment. Some people, again, Apache modules. And I think, Marco, you did a skill sprint showing how to use Apache modules today with, not with EMS, but with other servers. And then,
yeah, I did a skill sprint. It was like this summer, like end of June or something like that, for x86, showing the Apache support. And also a couple of tricks about Apache configuration.
Yep. So all of this will continue to move on and stay in touch, everybody, and we will keep you posted as always as we get to additional platforms. Let's see. Michael put in a licensing comment. Free data connection for trial use would be important to me for marketing. If that isn't free, I can't demo. Also, some limited free connection for non-paid users makes VAR work. So he's talking about the database side. There are many database options that work with FireDAC, right? That are free, things like Postgres or SQLite or MySQL.
Yeah, FireDAC supports all sorts of databases on purpose. I did 2 demos that used 2 different databases just to showcase that it's not Interbase only. Although Interbase again comes in the box for free. If the idea to provide a full-blown EMS solution for free with limited usage is something we could certainly consider, but it does have a few potential drawbacks in terms of, well, people just using it with no real licensing. So while we do understand that it would be nice to have something to get started, to get the full capabilities, and then start paying after, like, customers and users like it and adopt it, but it's not a very simple model to support in terms of enforcing the licensing afterwards. So the 5 users, the developer the developer version for 5 users is meant to be used for betas, for limited scenarios, to give it to a customer to try it out on the field. So it can be used for testing, but again, it's not meant to be used for real deployment.
Yeah, but for not only testing but demoing, it's fine.
Absolutely, yes. You just put that on your server and then run a client and show it to your potential customers.
And again, when you're using the testing versions with those licenses, you're going to be using the development analytics dashboard and the development EMS server, not the deployment.
Sure. Yeah, but you get the entire features, the entire capabilities, including the management console and the analytics, even in the developer version. So it's rather complete in terms of capabilities and feature. And then you just the same binary modules you are compiling would work in the ISAPI library.
And then Luis Felipe.
The other thing I wanted to mention is
Marco.
that we don't think that EMS is a universal model in terms of both the development and licensing that will will be ideal for every scenario, every application that our customers build. There are cases where EMS makes a lot of sense. There are cases where an SDK solution like DataSnap would be better. There are cases where actually you need millions of users and you need to use one of these BAAS providers. Or there are cases where the user will provide their own storage and with their private and personal cloud services. So there are many different scenarios, and EMS covers one of the areas of making data available to mobile. In other areas, you should probably look for different solutions.
And in this session, you showed connecting to SQL databases, but in your EMS business logic and implementation, you can connect to other cloud services, REST servers, whatever it might be, right? You're not limited in any way just to SQL databases alone. It's whatever is in your enterprise infrastructure.
Absolutely. You can even have custom APIs. So even services that just do calculations, compute something and don't even return data or data structures. Now, the specific focus of this session was EMS with databases. So that was my focus in these demos. And honestly, we are building the solution with a strong tie with FireDAC and databases. So it's somehow a priority or a core feature of the solution. But ultimately, you write some code on the server. The code can do anything. And what the code does is return some JSON data structures or even binary data or images or anything else. It's really a completely open and flexible solution.
And Luis asked, he's asking about, are there future plans for additional capabilities in the EMS server infrastructure? He's mentioning, it looks like maybe object storage, push, or whatever.
We do have plans around these types of features, yeah. So we'll see extensions to the EMS features in the next release of the product, and we'll keep adding it. I mean, it's a version 1.0, and it has the core foundation, it has the core capabilities, but there are a few things we certainly want to add. And if you have other ideas and requirements, feel free to let us know, and we can certainly keep EMS moving in its own roadmap, in its own track.
And again, the focus here of EMS is really, like the name says, for enterprises, inside firewalls and things of that kind. But you're not limited. You could put an EMS server in an Amazon cloud instance or wherever, right? But really,
yeah,
the focus we're on.
Putting EMS on the cloud makes sense if you also have the main database EMS is talking to in the cloud, well, possibly in the same cloud instance. Otherwise, if your database is behind your firewall, you should probably put EMS in the same physical architecture. Again, technically, you can do whatever you want, but it's just kind of a reasonable approach and a reasonable model for deployment. It's EMS. There are some of these MEAP services in which you're really forced to deploy on their own cloud systems. That might look like an advantage because it's something done for you, but ultimately means that the database conduit is limited. While of course, they only offer a few databases with limited bandwidth and generally cost a lot of extra money to talk with something like Oracle. but ultimately, it's in terms of security, in terms of controlling your own servers and your own destiny, it's not ideal. I mean, for a company, the fact that you can run everything where you decide, be it cloud, be your own servers, be your own infrastructure on web farm, and it's completely up to you. We don't bother. You can move things from one side to the other. It's not that you need an extra license if you move it to a different infrastructure. And it's completely up to you to pick the right deployment for the given task.
And then for me, one last question that usually shows up, but hasn't yet here, it showed up yesterday, is the relationship of EMS, which is all this pre-built functionality, connections are stateless, it's using REST and JSON, versus DataSnap, where you can do all sorts of things. If you want to build up your own infrastructure, the great thing about EMS is that all of this is pre-built, and you can put your logic into it and connect to whatever you need to. So maybe just a few words about, and here it comes,
sure,
DataSnap versus EMS.
The way we see DataSnap is more as an open-ended SDK. DataSnap has multiple phases. It started with socket-based binary communication layer with full connectivity. It added HTTP support. It added REST support on top of the HTTP support. And it is very flexible. It can be used in many different scenarios. However, for example, flexibility comes with a price that if you create the wrong DataSnap architecture or you don't clean up and optimize the code properly, you can easily get in trouble in terms of performance, speed, and the core capabilities. So it's very powerful because it lets you do an incredible amount of things, but it's also a little more error prone because you can really mess up things a bit inside DataSnap. The other side is that given there is some legacy in DataSnap, we plan moving it forward, but we'll have to keep that core infrastructure for the good or the bad, because we can't release a DataSnap that's completely incompatible from the old DataSnap. So while there are a few advantages, new features that we plan making available on DataSnap, the core will remain based around the current structure. With EMS, we had the freedom and the flexibility to kind of come up with a nicer and cleaner architecture. And it's not nicer and cleaner by itself. It's nicer and cleaner because it's extremely focused. It's completely stateless from the ground up. There's no option to make it stateful. It's completely sessionless. And it's really meant to be REST plus JSON structure. So it's really built on today's technology from the ground up. And that certainly provides some advantages. And by allowing a more limited set of options, it kind of guides the developers towards a model. And if that model is the model that's good for you, then EMS will be extremely powerful and fast to use and to build your applications and infrastructures with.
Well, thank you, Marco. Thank you for the back-to-back sessions today in the C++ track on CodeRage 9.
Sure. Thanks a lot. Bye.